Hello and welcome back to the Cyber Hero. Today in this video we are going to see in detail what are the digital signatures. So let's begin. Let me tell you what we are going to see here. First part we will say the introduction part. How digital signature works, some components, some algorithms, application, benefits, limitation. In last we will summarize this video. So without wasting any time, let's go for it. First, a simple introduction. A digital signature verifies authenticity, integrity, and non-repudiation of the digital message using cryptography method. What does that mean? In simple words, it's a cryptographic technique used to verify authenticity. What is authenticity? The message really come from the sender. The message really come from the sender. Then integrity, the message was not changed. Non-repudiation, the sender cannot deny it. The sender cannot deny sending it. So digital signatures are widely used in emails, software updates, documents, and secure transactions. How digital signature work? Main thing. Sender creates a hash of the message first. Sender encrypts the hash using their private key to generate signature. Receiver decrypts the signature using sender public key. Receiver compares both hash for verification. First, sender creates a hash of the message. Then, sender encrypts the hash using private key. This becomes the digital signature. Then, sender sends message plus signature. Receiver creates a new hash from the received message. Then decrypts the signature using sender's public key to retrieve the original hash. If both hash match, message is authentic and unchanged. I hope it's clear. So now see components, hash functions. It can be SHA-256, SHA-3, private key and public key. These are the main components. What is hash function? It converts into a fixed size value. Converts data into a fixed size value. Example SHA-256, SHA-3, SH512. Then private key, it's used by the sender to create the signature. Then public key, what is the public key? It's used by the receiver to verify the signature. I hope these components are clear. Now moving next, here we will see some algorithms, RSA, DSA, ECDSA. RSA is the most common and widely supported. Then DSA, digital signature algorithm, it's standardized by NIST for government to use. Then this ECDSA, it's a faster and more secure with short keys. This one is faster and more secure with short keys. Then we will see some, now we are going to some real world applications where it's used in email security. How? It ensures the sender is authentic. Software distribution. The companies sign updates Windows, Apple, Android to prove legitimacy. Legal and business documents. Use just like Adobe Sign-in, DocuSign, blockchain cryptography. Every transaction is digitally signing using private keys. So this was some real world applications where it is used. What are the benefits? Security, obviously, authenticity, integrity, non-repudiation, trust, and prevents message tampering. Then some limitations. Requires secure key management. Loss of private key is critical, because if the private key, loss of private key, there is no use of using digital signatures. So it's a critical. Let's summarize this video. Digital signatures play a vital role in secure communication, legal verification, and blockchain technology. How the data come from the correct sender, it was not modified, the sender cannot deny the action. They form the backbone of secure communication, legal, digital agreements, and blockchain system. So this was all about digital signatures. If you learned something new today, please hit that subscribe button. See you in the next video. Bye bye. Take care.